In solving trigonometric equations, we often have the functions in a form that makes the equation difficult to solve. However, we can use trigonometric identities to get these equations into a form that will make them easier to solve. You've already seen some of these identities in the first lesson, where we've discussed the functions themselves, but it's nonetheless worth reminding yourself of these, just because of how useful they are. There are, however, some identities which are less obvious than those, for example the two listed below. Let's now look at the proofs of some of these identities. Firstly, the most important, sine squared plus cosine squared equals 1. Going back to the unit circle, we had this diagram where the sides of a right-angled triangle were equal to sine, cosine, and 1 respectively. By the Pythagorean theorem, we know that the three sides of a right-angled triangle follow this rule: a squared plus b squared equals c squared, where a and b are the two shorter sides and c is the hypotenuse. In this case, the opposite and the adjacent are sine and cosine, and the hypotenuse is 1. So therefore, sine squared plus cosine squared equals 1 squared, or just 1. Here are the proofs of the other identities. Firstly, the 1 plus tan squared equals secant squared identity. You can see that tan can be expanded into sine squared over cosine squared, which can then be simplified into cosine squared plus sine squared all over cosine squared. And since we know that cosine squared plus sine squared is equal to 1, this is just equal to 1 over cosine squared, which is secant squared. 1 plus cotangent squared can be expanded into 1 plus cosine squared over sine squared, which can then be simplified down to sine squared plus cosine squared all over sine squared, which is just 1 over sine squared, which is just cosecant squared.